Good afternoon, class. Good to see everybody here today. We are going to talk about what today? Characteristics of function graphs. And we're going to build upon what we talked about yesterday when I was talking the whole class period. And maybe you'll help me out by talking more this class period so my voice isn't going to get as tired. Okay, we have this first problem, or this first graph, where we have the value V in millions of dollars of a stock portfolio as a function in time t in months over an 18-month period. Now, if you've ever seen a stock price chart, does a stock price chart look like this? No, it's more random, right? Like you would see, like it'd be like this, and then stock prices went up, and then COVID hit, and now stock prices have come back, right? So that's more what a stock price chart will look like. But for the purposes of this problem, we are going to just answer this. So what you're looking like is you have time, months, and here we have t on this x-axis. So we will say t equals the months. And then how would you label the variable on the y-axis here? What would be the function notation? How would you do that?
Dollars, D.
You could do millions, you could do dollars, you could put dollar symbols, right? Dollars, like millions of dollars. But typically what you'll see is function notation, where you'll have the letter here, but then you're going to go ahead and put parentheses, inside the parentheses, the independent variable. So you have t and v of t, right? Independent, dependent. And remember, you remember the song I just sang to you? What did it say about, did it talk about money is usually dependent? Do you remember that? And time independent? Isn't that exactly what you see here? Money is dependent and time is independent. That's the way it usually works. It's just because it's a real life application. Okay, and so here we have this graph, and we are asked these three questions below. On what interval is the function decreasing? And you remember what an interval is? So what we have is, Bryce says that's part of a number line, right? It's kind of like an unbroken part of a number line would be an interval. So on what interval is this function decreasing? So 3 to 13, is that right? So we'll say v of t is decreasing on, and we're going to say, did you say 3 to 13?
Yes, sir.
Okay, so 3 to 13. And when we say on, that's code for on the interval of. Okay, now on what intervals is this function decreasing? Or increasing, excuse me. What intervals are we increasing?
0 to 3 and 13 to 18, 19, whatever.
So was that you, Jaden?
Yes, sir.
So 0, 3, and then 13,
To 19.
comma,
The 19 or 18?
looks like 18 to me, right? And what do we put in between these two intervals here in interval notation? A U, right? Yeah, thank you, Ben. Interval notation, U. Very good. The next, any questions on this so far, on 1 and 2? Okay, identify any maximum values and minimum values. Okay, so we have maximum value of
3.
3, and usually we want to say where it occurs. And where does that occur, the maximum of 3?
18.3.
At x equals 18, right? Any other maximums?
No.
Right here's a maximum too, right?
Wait.
So we got this maximum here already, but do we have another maximum? Yes, we do. What is that maximum?
2.5.
So 2.5, Marcus, at x equals 3. Okay, that's good. And what are the functions domain and range? So I'm going to put domain here. So 0. Oh, is that going to be bracket or parentheses? Bracket. 0 to 18. Now what's going to be our range here? What is our lowest value of V of t here?
1.75.
0.75?
1.75. Oh, 0 to 1.75.
Yeah, so 0.75. Now, I'm going to do a lot of time when we have like 0.75 would be a correct answer, but a lot of times I'm going to put 0 out in front. And that's just the way people do it. Why do people put 0 out in front? Where you don't, why don't
Why
have
is it
to?
not 0? Why is it 0.75?
Why put a 0 out front here of the 0.75?
I guess I don't think it's like that you're doing.
And the reason is that you don't want to, you want to make sure, because if you just put 0.75, what it is, you're just making a statement that you're making extra sure that it's understood. And so you see that way written in math books about point, you see that, right? 0 point something.
Well, where are you getting 0.75 from? Wouldn't it be 1.75?
Okay, so if we look at this over here, we have 1 right here, right?
Oh, it's the lowest point?
And 0 here.
Okay, I see what you're
So we're going right, and it looks like we have 4 of these marked.
I thought y'all were going as like the
Between
Y,
0 and 1.
like where it wasn't the Y thing.
Okay? Any questions on this? Good job. Thank you, everybody, for helping me. That's been really good. Really good. All right. Next, the table of values gives a probability P of n. Again, that's the same notation as before, right? Remember I had V of t? Well, here we have P of n and n. And so you have a table there. And then you have the question there. Is P of n increasing or decreasing?
Decreasing.
So decreasing. Marcus says decreasing. Is P of n really decreasing? It looks like these numbers are getting bigger. I'm seeing 6, 36, 216. Why is because the fraction, right, in the denominator. So we'll say decreasing. And explain the significance of this. How do you say that in English? Translate to English. I have a version if nobody else comes up with something. How do we translate that to English?
The denominator, they small, or bigger.
Okay, the denominator gets bigger as the denominator gets bigger, and I was thinking of a different explanation, but that's a good one. So I'll just say, I'll go with Marcus's. So the denominator gets bigger, and correct me if I'm wrong on this, denominator increases as n increases, right?
Yep.
Would that be a good way to say it, Marcus?
My interesting would,
Yeah, go ahead.
it,
Oh, you take the pass, all right. Now, what is the end behavior of P of n? Now, we're getting back here to our end behavior notation we started out with, we talked about last week. Beginning of last week, I think it was, or I don't know if we talked about in the first. How did that notation go for end behavior?
As X approaches.
As x, right? So as, in this case, do we have x? No. As n approaches infinity, P of n, oops, P of b, I don't know why I put P of b. There we go. P of n approaches zero. Is that Ben? That was Ben. All right, good job, Ben. Yeah, as n approaches infinity, P of n approaches zero. So that's, any other way to say that as far as that goes? Now explain the significance of this. What's the significance of this?
Continuous downward curve.
Yeah, so you can just translate this English. So and it's similar to what Marcus would write, as n gets closer towards infinity, probability approaches zero, right? Now, I want to tell you something I did in my own. I also did some predictions and probability. I want to just kind of go over this briefly. My wife and I together have had 3 children, and what I did is I correctly, in advance of knowing which one would be a boy and a girl, I correctly predicted what each of those 3 would be. The first time I predicted a girl, and a girl was born, right? So what's the probability that I predicted correctly?
50%.
50%, or 1 out of 2. And then the second child was getting ready to be born, and I predicted that she would be a girl, and I was correct. So what's the probability that I would get 2 of those predictions correct in a row? 1 out of 4. Okay, now finally we have another child getting ready to be born, and I correctly predict for a 3rd time in a row that this one would be a boy, and I was right. So what is the probability that what I predicted actually happened? 1 out of 6? 3 out of 6? 3 out of 6, would that be right? Remember, we went from 1/2 to 1/4 to 1/6 would be 1/6, 2, 4, 6. Is that right? It's not 1/6. It'll be 1/8. Okay, let's talk about that. It'll be 1/8 because what? What you got to look at is the probability is going to be 1 over 2 to the power of n, right? And what happens if you replace n with 3? You get 1/2 to the power of 3, which is going to be 1 cubed over 2 cubed, right? Which is going to be 1/8. All right? So just something, we talked about that in an earlier class. Okay. Let's go on to the next one here. So here we're talking about average rate of change, one of the things we talked about yesterday, right? And so we're just looking at certain intervals, on which intervals the function average rate of change positive, select all that apply. So we should be able to look at this and go through these 6 pretty quickly. So from x equals 0 to x equals 1, do we have a positive rate of change or not?
Positive.
Positive? Because 75 is, oh, it's a rate of change of, who said 25? Yeah, rate of change of 25 is what it is, which would be the slope. So I'm just going to circle the ones that are and just X out the ones that are not. Now what about from x equals 0 to x equals 2?
No, negative.
Negative, right? Down 10, so cross that out. What about between 0 and 3?
Positive.
Positive, right? And that's the entirety of the domain. What about between 1 and 2?
Negative.
Negative. And between 1 and 3? Negative. Negative. So that's, and finally between 2 and 3? Positive. Okay, so next we're going to go to problem 7. And in problem 7, what are we being asked to do that we weren't asked to do in problem 6? We're actually to find what that rate of change is. And what do we need to do to find that rate of change? A what? What do we need to, what do you need, Riley? Anybody?
What are we looking for?
What do we need to have to do this, to figure this out? I think we talked about it
Wasn't
yesterday.
that the slope?
That is the slope, right? So what do we need to calculate slope? A slope
The thing we did yesterday.
equation or formula, right?
Yeah.
Equation or formula. And so we talked about different forms of the formula. We talked about this one, average rate of change.
Oh, yeah.
We talked about f of x2, right, minus f of x1 over x2 minus x1, right? Or we also talked about, remember I told you, didn't I tell you yesterday about in calculus the form we use here, in calculus most of the time, like you have f of b minus f of a over b minus a. Did I talk about that yesterday?
I think so.
You don't remember? Okay. What happens, I have different class sections and I don't remember perfectly what I've talked about in prior classes. You understand why that would be the case? Okay. But even though we use this form in calculus, is this a calculus concept we're looking at here? No, it's not.
Oh.
It's just M, right? It's algebra 1. Or even you guys might have even learned this in pre-algebra, I don't know. But, so let's go ahead and use our formula to find these out. So for A, we're looking for a rate of change between x equals -3 and x equals -2. So I'm just going to go over here to x equals -3 and just write this, I'm going to change to red just for better visibility, I hope. So here we have our coordinate pair I'm going to write down as -3, 0. Is that right?
Mm-hmm.
So that'd be this point right here. And then for x equals -2, we're right here. So we have -2, looks like 2, right? So now to find our average rate of change, which formula do you want to use here?
The top one.
Top one? So here's x2 right here, right? What's f of x2?
2 negative 2.
2. f of x2 is 2, right? So we put 2, and we know we're going to have to divide by x2 minus x1, so I'm just going to put minus 2 down here, right? x2, f of x2, x2, right? Minus, and now we put f of x1. What's f of x1? 0. And what's x1? Negative 3. Okay, what is this thing going to simplify to here?
2 over 5.
2 over,
Negative 5.
I'm thinking 2
That'd be
over 1. 2
Yeah.
over 1, right?
Right.
So 2 over 1 equals 2. So that's going to be our average rate of change. And graphically, we can see why that's the case, right? Because if we look at this right here, we're going to go up 2 over 1, right? Okay, now from negative 2 to negative 1, we've already established this point, or negative 2 to 1. So here at 1, we have the coordinate pair 1, comma, negative 4, right? And what is our average rate of change going to be here for this one?
2, wait, yeah, B.
Negative 4, right? That's going to be our, because we're x equals 1, and we're going to put 1 down here, right?
Yep.
So f of x2 and x2 minus, what do we put up here?
2.
So we're going to 1, so we put in 2, and then here, negative 2, right?
Oh.
And what is this going to simplify to?
Negative 6 over 1.
So negative 6, I'm looking like
3.
a negative 6 over 3. Here's negative 6 over 3, right?
Over 3.
So that'd be negative 2.
Negative 2. And just to verify, we go down this far, right? We're going down 6, but over 3. So we have negative 6 over 3, all right? Which is negative 2. Now next, between 0 and 1, well here, we already have 1 figured out, but between 0, we have this thing down here, right? Which I'm going to call, let me erase this thing a little bit. We have 0, comma,
Negative 3.
negative 3. So how do we do this one here, between 0 and 1? Well, f of 1 is what?
Negative 3.
F of 1, I'm looking like, looks like negative 4, right?
1.
So negative 4. So we have f of x2 over x2, right? Then subtract out f of x1. What's f of x1? Negative 3 over x1, which is 0. So what do we have here? Negative 1 over 1, which is negative 1. Is this halfway making sense to you? Is it hard to keep track of the numbers a little bit?
Kind of.
And one thing that is helping, what do you think is helping me today? This is my third session of the same subject.
It's like one of those things that you gotta just like, the more you do it, like the better, like you remember it.
Yeah, but I'll tell you one thing though, is because of that, sometimes it can be easier for you to make mistakes too.
Right.
Because I'm thinking I'm an autopilot when I really need to be thinking actively. Okay, from 1 to 2, so here at 2, we need that point, right? So I'm thinking 2 comma 0 here, is that right? So here we have f of x2 is what? 0. And x2 is 2. And then we just go minus, minus. And then we're going from 1 to 2. So what's f of x1?
I want to say -3. Wait, -4.
Negative 4? I'm thinking negative 4.
Okay.
And minus 1, right? Because that's x1. So what do we have here?
-4 over 1.
4 over
Positive
1
4 over 1.
equals 4. And we could see this, right? We can go up 4
Yeah.
over 1. So that makes sense if we look at it that way. Is this pretty hard to see on your paper? Just because it's small?
There's no lines or things. There's
So
no
you
lines.
can't see the line. So lines are faded out, is what
Yeah.
you're saying. Yeah, sometimes in the printing, those lines get faded out. And so that's helpful in this thing because you're talking about pretty incremental, okay, it's pretty detailed. In E, we have from -1 to 0, and I think we already have, no, we don't have -1 yet. So -1, we have -1 comma 0, right? So now for this one here, we have f of 0 is -3, right? And x2 is going to be 0, and we're going to go minus minus, and -1 is going to be what?
0.
Okay, yeah, minus 0, and this one here is going to be -1, right? So what is that going to be? -3 over 1 equals -3. And finally for this one, we're going from x equals 1, -1 to x equals 2. So we go to 2 here, we have 0, which is f of x2, and then x2, which is 2. And then over here, for -1, we have 0, 1, right? Or -1, 0, right? So we put minus 0 and minus -1. What's that going to be? 0 over 3, which is equal to 0. Now, on what intervals are the function values positive? That's 8. And I'm going to put we're given f of x here in the notation. So we're going to say f of x is greater than 0 on what intervals?
8.
Where do we see the function values positive?
A and D. Like on the question.
Right here. I'm looking at between -3 and what? And -1. You see this graph comes up above the x-axis?
Oh, no.
And where else are the function's values positive? Two, right here. So 2 all the way to less than infinity. And then for 9, we have f of x is less than 0 on which intervals? -infinity to -3, right? And also between -1 and 2, right? And if you look at the intervals, you can kind of see that this piece here is filled in between where the increasing is not. What are the zeros of the function? Zeros. What are the zeros of this function? X equals what?
-3.
-3. And what else? What's this zero here?
-1.
-1. And finally,
2.
2. Okay, let's quickly look at this one here. You have this describing the United States nuclear stockpile, and what you have here is years. So we'll say let x equal years, since 1944. Okay? Because that's what we're given here. So between 1944 and 1958, there's a gradual increase. So 1958 turns up where on this graph? 58 minus 44 is?
14.
14. So we go to 14. How many thousand warheads did we have here? Okay, we started at 0 warheads, because that was like the beginning of the atomic age, and we went to 5,000, right? Okay, the next thing, we have from 58 to 66, there was a rapid increase. So in 66 to 44, how much was that? 22, right? So 22, we're going to go up to a maximum of 32,000, right? So go right up here to 32,000 right here. That's right here. There we go. And next we have is from to 1970. Okay, when's 1970 in this scheme here? 26. So 26 goes about right here. How many warheads did we have? Well, we went down to 26,000, right? So we go to 26, which is about right here. And then from to 74, there was a small increase to, okay, we already had that. Oh, then we had, yeah, from 74, there was a small increase to 28,000 warheads. What year is that? 30, right? So 30, we had a small increase to 28. And so, is that all the data? Yeah, it is. Do we have to draw any lines between them?
No.
No, we don't, but if you do, I recommend just drawing like dashed lines like this. Okay, so is that it? We went over that pretty quickly, but we sort of ran out of time toward the end of class. But that's all right, we had good discussion. So yeah, we'll just turn this in. And if we could have